Hello there, YouTube. So I got an awful lot of feedback on my latest video about why I thought the Beirut explosion was red. And my contention is the majority of what you're looking at here is just the soil being blown into the air. And I got quite a lot of comments saying that they thought I was wrong, and a lot of them have provided fairly sensible, reasoned arguments for this. Like this guy. Some others were a little less reasoned. Some people just like the sound of their own voice. This would be a lot more believable if I was listening to an expert instead of a guy reading straight from Wikipedia. Okay, if it helps you take me credibly, you can pretend that I've got a PhD in chemistry and 20 years of research experience. Anyway, so yeah, I'm always sort of a half and half about with these things, whether it's that I just didn't explain myself well enough or what. Anyway, so I'm going to have another go at explaining why I think this really was just the soil being blown up, and why I think a lot of these people are suggesting that it's nitric oxides or nitric oxides. And there's quite a lot of things that they cite where I think they're wrong here. Right? And we're going to start with, straight off the bat, the aftermath pictures, where you can see there is a fairly sizable crater. This used to be all docks here. And now all of that earth and soil, that was blown into the air with the explosion. So you know straight off the bat, just the mass balance, that a lot of what you're looking at there is just the stuff being blown into the air. So what you're probably looking at is you have a very large explosion here, and it sort of scoops it all off to the side in the explosion. And I think that's a lot of what you're looking at. And incidentally, quite a lot of people were saying that I was an idiot, that this is all grain from the silo, and for some reason the grain from the silo is leaching into the water and making it red. Anyway, there's a gazillion pictures now of what the locality of the explosion looks like. And this is all pretty ferric looking soil, fairly similar to the colour of the explosion. But, this bit here where it looks wet, and this is pretty similar to what you see in the explosion, where it goes boom. Yeah, this looks very ferric. Now, it's true that these nitric oxides can also be red, and, for certain, some of this will be those nitric oxides. Incidentally, this is fascinating as well. This gives you a clock on how long the fire was actually burning before it exploded. So you get a rough idea. It's about a minute by the looks of things. This guy started filming about a minute after this started to burn. And the one thing you'll notice is when it's burning, white plume, no brown smoke or anything, which is maybe important. We'll come back to that later. The other thing that's fairly critical here is just the general geology of this area. That if you take a look at the sort of locality that we're in, it's all pretty reddish, ferric-y soil in this neck of the woods, and the only bit that changes is as you get close to the coast, you get some rain from the ocean, which makes it look a little more green. But this is likely to be the sort of sandbars that you're looking at, and it's all fairly ferric-y. That'll be this sort of ground that this was built up on, and it's just black topped over the top. And you can sort of see how much of this was actually blown into the air with the explosion. So that's what I think the lion's share of what you're looking at there is. So, what about these people who think that it's nitric and various oxides of nitrogen? Well, they mostly cite a study from the CDC. The Center for Disease Control. And the reason they were interested in it, of course, is people use this for blasting in things like mines. The nitric oxides themselves are pretty toxic. They're toxic in the parts per million range. So it's actually sort of fairly important that you get a reasonable handle on how much of these nitric oxides you're going to expect to have after the explosions if you're using your ammonium nitrate as part of an explosion. And there are even some mentions here that there are explosions that produce reddish orange product clouds. And I want to make a sort of distinction. We've got to be, if we're looking at a brownish gas, then absolutely, yeah, fine, I've got no problem. But this doesn't look like it's the gas that's actually giving you the color here. That looks more like the soil. And yeah, I did mention this on some of the other videos that I linked to my last video. This is they're blowing up some ammonium nitrate in the desert in Iran. And this brown color I can quite happily accept. This is residual nitric oxides of one sort or another. And, you know, when you get the immediate blast, there's nothing. This is what you expect. There is nothing in the immediate blast. And then later on, some of these mix with the air, it goes brown. Right? That I can quite happily say is the various oxides of nitrogen. But if you come to the CDC, they're interested in basically the toxicity of the gases that are left afterwards. If they're really toxic gases, you're going to make sure that if you're using to blow up things in mines, you've got to clear out the fumes first. And yeah, important things, you get a couple of these. This is the one that you mostly get, is the nitrogen monoxide, which oxidizes very quickly in the atmosphere to give nitrogen dioxide, which is the fiercely brown one. So you expect most of the stuff in the explosion, which is very hot, to be this guy, and then as it cools down, it goes to the dioxide, which is what you were seeing here. That's why initially it's a sort of fairly clear explosion. Anyway, they go on and they do some test explosions and they do some monitoring of the residual gases after the explosion. And they're finding these things present in hundreds of parts per million, that sort of ballpark. So just so we're all clear, 1 million parts per million is 100%. So 10% would be about 100,000 parts per million. Right? Now, some of the comments on this were actually putting in equations, which even if they were balanced, they just look way off. They're way off for other reasons as well. But I'm just going to take this as all gases occupy basically the same volume. A mole of a gas occupies the same volume. So a mole of nitrogen occupies the same volume as a mole of nitrogen dioxide, nitrogen monoxide, or steam. This in the explosion will be given off as steam. It's just a regular gas. So you just count up the moles that we've got here in this guy's equation, and it's 2, 3, 4, 10. 10 moles of gas, of which he reckons 2 of them nitrogen dioxide and nitrogen monoxide. So that would mean that in the explosion, you would expect about 200,000 parts per million nitrous oxides, or nitric oxide, sorry. Whereas in reality, it's 1,000 times lower than that, is the ballpark numbers that they're finding here. And there's another reason why that's probably the case, and that you've got to understand a bit about how all of these things explode. This is probably the most important element. This is the nitrate in the ammonium nitrate. So you've got your ammonia, your NH4, and your nitrate, NO3. The reason why nitrate is so common in so many explosives is because it almost doesn't matter how you arrange the nitrate molecule, the nitrate atoms, you'll get to something more stable, like nitrogen or oxygen and so forth. So when you get this stuff burning, it decomposes. It kind of looks like it's a flame, but it's not. There's no oxygen being consumed in this. It's just decomposing. It's called a deflagration. It's a sort of fairly rapid burn, and that's what you see in the early phases of this warehouse explosion. That's when it's putting all the white billowy flames out. This is not that. This is just the ammonium nitrate burning. However, it can swap to this different mode of decomposition, which is a detonation. And what happens with the detonation is if this decomposes and keeps a lot of the energy in a sort of fairly small area, the molecules coming off this have enough energy in them to cause a similar decay in the adjacent molecules. So what in practice happens is it's basically a chain reaction. So the decomposition goes through the entire of the solid of the ammonium nitrate at about the speed of sound in a solid, which is about, give or take, 10 kilometers per second. And what you get in that, there's obviously quite a lot of energy in quite a small area. That's basically, it all happens in 30th of a second or so. So that's there. That's the entire energy releases basically in one frame, and then after that it's just the adiabatic expansion of the gases. So when you get that really hot area, what tends to happen is all the molecules are kind of smashed up, and what emerges first, and this is what releases a load of the energy, is the formation of the more stable molecules, things like nitrogen, oxygen, and water. So that's why the main decomposition products you expect from a detonation are the most stable molecules. Now, with explosions, there's all sorts of energy and mixing up of this, that, and the other going on. So you get a load of side reactions of one sort or another, and it's inevitable. Even if you get nitrogen and oxygen very hot together, you'll get some nitric oxides. Or, it can be from a partial decomposition of the nitrate. But these are not particularly stable molecules, which is why you don't expect to get a lot of them in the decay products of an explosion. Parts per million, that's perfectly within what you might expect, but you don't expect a lot of these things in the decay products from an explosion, because these are still pretty unstable, pretty high energy molecules. This one, nitrogen monoxide, oxidizes in our atmosphere very quickly to give nitrogen dioxide. That's the one that's brown. And this is rocket fuel. This is genuinely just used as rocket fuel. It's still that powerful and reactive of an oxidant. Now, so that's what you're going to get in a neat explosion. The problem is that it's very difficult to find a neat explosion of ammonium nitrate to compare this to, because the only time you get these sorts of explosions are when basically an ammonium nitrate depot blows up. So a storage area or a ship carrying ammonium nitrate, and there's not a lot of footage of that sort of thing. There's quite a lot of footage of people blowing these things up when it's used as a sort of quarry explosive. But when you do that, this is the majority of the decay products that you get out when your ammonium nitrate detonates. And you've got quite a lot of oxygen there. So the thought occurs, okay, we'll basically put some gas in here. Enough gas that it reacts with all that oxygen, releases even more energy, and makes carbon dioxide and some more water in the decay products. And that's the explosive that they were talking about in this whatever, ANFO or whatever it is. Where are we at? Whatever, some 4-letter acronym. Okay, I'm not saying that. Anyway, it's basically ammonium nitrate mixed with fuel oil of one sort or another. It increases the yield of the explosion, and that's a good thing for this. So a lot of the test detonations that you get, they actually have ammonium nitrate mixed in with the fuel oil. There we go, the ANFO. And so it's very difficult to be certain that the explosions that you're looking at are just ammonium nitrate or they're ammonium nitrate mixed with fuel oil. The one that I was looking at earlier, this claims to be the US military blowing up just the fertilizer. So people can use the fertilizer as a sort of precursor to making these bombs. They claim that's just the ammonium nitrate. But there are other things where there is some footage of things that have carried ammonium nitrate blowing up. One of them is this tanker truck. There was a tanker truck carrying ammonium nitrate that exploded. And you do get a sort of brownish cloud off of this. But it's really not this intensely red cloud that we were getting off our Beirut explosion. And there are several other people who have sent me things like this. This is not ammonium nitrate explosion. This is just a nitrogen dioxide leak. And that just gives you a sort of baseline for what these things might look like. And yeah, so this is another one. This is one that we were looking at earlier.
Explosive mixture called ANFO.
So this one claims to be the ANFO. This is mixed with a fuel oil. And there's really not a lot in the way of brown smoke there. But, you know, I could quite happily believe they've overdone it a bit with the fuel oil. And this is basically soot in the air that you're looking at. So, and yeah, there were other people who said there was something like this in Mexico. I couldn't find any sign of it. So the ones that I'm fairly certain of are the truck exploding. That, I think, is a fairly good exemplar of what you expect the nitrogen dioxide in an ammonium nitrate explosion to look like. And there are some pictures in the aftermath of the Beirut thing that look like this. But I don't think that's what you were looking at here. This just doesn't look right. You know, plus, you know, when the explosion first goes off, at best it should be nitrogen monoxide, which is colorless. It should turn brown after a few seconds. So, those are my additional thoughts on why I reckon still that the majority of what you're looking at here is just all that red dust being thrown up into the air. So, it doesn't mean I'm right, of course, but to me this feels a better explanation of immediately what you see here. Yeah. Okay, so let me know what you think. Thumbs up would be nice. And as ever, if you feel like supporting this channel through Patreon, links below. And thanks for watching.